Design of slab base problem. Design a slab base for a column ISHB 300 at 577 Newton meter carrying an axial factor load of 1000 kilonewtons. M20 concrete is used for foundation. Provide welded connection between column and base plate. To solve the problem, first step number 1, given data. Step number 1, given data. Suppose given data is equal to 1 is equal to column size is equal to ISHB 300 at 577 Newton meter. Axial factored load PU is equal to 1000 kilonewtons is converted to 1000 multiplied by 10⁻³ Newton. Grade of concrete is equal to M20. Therefore, FCK is equal to 20 Newton per mm square. Therefore, step number 2. Draw the diagram. Length of the base plate. This is equal to length of the base plate. This is equal to width of the base plate. This is equal to length of the base plate, L. This is equal to width of the base plate. Therefore, slab base therefore column size is equal to small b projection, small a projection is lengthwise, small b is equal to, and L is equal to, you find out L is equal to, and section, draw the section. This is equal, first step is equal to RCC. This grade of concrete is equal to M20. This is equal to, second step is equal to base plate, and the third step is equal to column. This is equal to column, this column, this is equal to cleat angle, this is equal to cleat angle, this bolt, This is equal 4 numbers of J bolts. This is equal column size HB 300 at 577 Newton meter. Therefore, this is equal to width of the base plate is cleat angle. This is base plate size. This M20 concrete. This is equal column. This is equal column load. This plate. This figure. Explain just. This figure. This is equal L is equal length of the base plate, B is equal breadth of the base plate, and A is equal projection of the base plate lengthwise. B is equal projection of base plate widthwise. Therefore, calculation of area of the base plate, this is equal to A, and length of the base plate and thickness of the base plate. This is equal to step number 2. Step number 2. First, bearing strength of concrete. Bearing strength of concrete. The formula is equal to IS 800 2007 and page number 47. Page number 47 and clause number 7.4.1. Therefore, formula bearing strength of concrete is equal to 0.45 FCK. This is equal bearing strength of concrete. This formula where FCK is equal to 20 Newton per mm square. Substitute 0.45 into 20. Here calculate 0.45 multiplied by 20 is equal to 9. This is equal to 9 Newton per mm square. 9 Newton per mm square. Next, step number 3. Therefore, area of base plate. A. Therefore, 1 is equal to length of base plate is equal to L to width of base plate is equal to B. Therefore, 3 thickness of base plate TS. Thickness base plate TS. Therefore, area of base plate is equal to area of base plate. 2 types only. One is equal to required area of base plate is equal to A required formula axial load by is equal to PU by 0.45 FCK. Therefore, where PU is equal to 1000 multiplied by 10⁻³ newtons and already calculated is equal to 0.45 FCK is equal to 9 Newton per mm square. Therefore, substitute A required is equal to 1000 multiplied by 10⁻³ by 9. Therefore, calculated A required is equal to 1111 mm square. This is equal to A require. Therefore, 2 size of base plate is equal to A is equal to L multiplied by B. Base plate, this is equal to size of base plate. Therefore, L is equal to B is equal to root of A. Therefore, L is equal to root over of 111 is equal to 3.33 mm. Say, hence provide 360 mm. Hence provide L is equal to 360 mm. L is equal to 360 mm. Therefore, you mark the L is equal to 360 mm and calculate B. Therefore, width of base plate is equal to width of base plate is equal to area by 111 by 360 is equal to, you calculated 308.64 mm. Say 310 mm. Hence provide small b is equal to 310 mm. Therefore, size of the base plate is equal, hence provided size of base plate is equal to 360 by 310 mm and mark small b in figure small b. Therefore, small b is equal to 310 mm. Small b is equal to 310 mm. Check A required area less than A provided area. Therefore, A required area is equal to 111 mm square. Provided area is equal to, therefore, where A provided is equal to 360 multiplied by 310 is equal to 11160 mm square. 11160 mm square. Therefore, hence safe.